Hey guys, welcome to another session of Leetcode problem solving. We are going to solve this question. It's called majority element, and we just need to find out the number that appears more than n by 2 times. Note that if one specific number appears more than n by 2 times and it's guaranteed to exist, then no other number will appear more than the majority element. Okay, so the first solution that comes to my mind is the brute force solution. It's the naive approach where we basically sort the array first. Obviously, that will take n log n time because we're sorting the array. And then we will just keep track of the values and return the majority element. But that will have O n log n time complexity and O1 space complexity. Let's think about other solutions. I guess the other solution is to have a hash map where we can implement the the integers at specific keys. So yeah, so the array value can be our hash map key in the hash map, and the actual value inside the hash map can be the number of times it has appeared, and then we return the highest value in the hash map. That would take on space, but it would actually also take on time, I guess. So if we put the entire thing in a hash map, that would take on space. But after that, the to actually put all of those values in the hash map and updating each of their, like the number of times they have occurred in the array, that would take on time too. Then after putting all of them in the hash map, because we want to track the key with the highest value, we don't know which one has the highest value, right? Because insertion is O on time, but in order to find out the one with the highest value, we still need to iterate through the hash map. So that's another O(n) time complexity. So that would be 2 O2n, which is still linear time. Okay, so yeah, so that would be slightly better than the naive approach. I guess we are going to go with the hash map. I can't think of a better solution. So, and in order to iterate through the hash map, I did a little bit of research, and it says we need to implement a map.entry interface in order to iterate through them once we put all the elements from the array into the map. So yeah, so it's gonna have a map interface, and I guess the key is going to be integer because that would depict the number that we're inserting, and the other second integer is for the number of times that key has occurred inside the array, and we can say num count for the name, new hash map integer. Okay. Cool. Right. Num count dot put So if value does not exist in hash map, num count, num count dot get what was, let me see, hash map num count, hash map get value. How to get the hash map get value? Get the value of key 3. Okay, so get dot get, that's all we need to do. So yeah, let's go back. Num count dot get, get the value in nums I. We need to embed this in a for loop. And if this entire thing is equal to null, then num count dot put nums I, and since it does not exist, we put 1 because it has occurred one time. So for let's use this opportunity to find out how to the easier, the more smarter way to syntax a for loop based on the number of elements on an array. So for loop, iterate through array syntax. The one where they use the clone. I just want to learn how to use that. Okay. There you go. Data type of array or list. Temporary array name. Yeah, there you go. So integer string temp. Wait, what? Java provides a way to use the for loop that will iterate through each element of the array. What is string temp? Okay. I think I got it. Let's use some other enhanced for loop, enhanced. Yeah, it's the same freaking, where is it? Yeah, so what happens in the enhanced for loop, I guess, is they take the array index starting from the top all the way until the end, put it in my value, and whatever you want to do with my value, you can do it, okay? So we're just gonna go back to Leetcode and we're gonna use this opportunity to write an enhanced for loop. So I guess it's gonna be int, wait, they use int or integer? Okay, int, yeah, why would they use a wrapper class in a for loop? Okay, anyways. Int, I guess and then what? And then a colon. I guess that's what you call it. I'm gonna Google this too. I'm so distracted. Colon, punctuation. There you go. It's called a colon. Anyways, so for int I, nums, right? MyArray, that's what you call it. MyArray.length, makes sense. Nums, cool. And I'm gonna have this if statement inside of here. Hash map to store count of num occurrences. Iterate through array for every single iteration. We store it in I, and I guess that's why we just need to get this, the key, the value associated with the key I. If it does not exist, if the value does not exist in the hash map, we put the value with 1. Else, that means a value does exist. All we do is we put in the same index, in the same index, we put numCount dot get I plus 1. Let's put a bracket on this too. Cool. Whoa. So if the value does exist, then in the same index, we put the existing value and add 1 to it. So we're done populating our hash map, and this will take on time. Let's just write that down. And then what we need to do is we need to iterate through the map again so that we can find out the key with the highest value, and that is our answer. So I guess this is where we utilize the interface, map.entry. Map.entry. Where is... Okay. Yeah. Let's just put this here. Integer. Okay, they used an enhanced for loop over here too. Let's just copy this. They used an enhanced for loop here too. What does this mean? Well, this is what, I guess this is what used to iterate through the map, because hashmap doesn't allow that functionality. So all you need to do map.entry integer, and it's gonna be called entry, so it's fine. And we change numCount into an entry set using a map.entry interface so that we can iterate through it, and the enhanced for loop asks us to iterate through this. So I guess what this code does here is it takes numCount, it converts it into a set that we can iterate through, and the enhanced for loop iterates through that for us, and stores the value in another entry. But won't that take more space? What? That's supposed to take more space. Okay, yeah, I probably don't care much. I'll try this later and see if it actually does take more space. But entry.getKey Do we want to iterate like this? I guess the other method would be to actually put the entry set into a set and then use an iterator to iterate through the set, which is pretty much the same thing. So we can use a map entry interface to iterate through it too, using an enhanced for loop, and that's fine. Go through map and get highest. So this is also on. Okay, so for map.entry, so for the given entry, I guess we have int max count, integer dot min value, so that it has the absolute minimum value. So max count is equal to, actually you don't need to initialize this, fine. So if the array is actually nums null, return null. If the array is empty, we don't want to do anything. But if the array is not empty, then we want to iterate through them. Put it in a hash map. If entry dot get value, okay, so if dot get value is greater than max count, that means we need to update int majority max count and int. Okay, so max count is equal to entry.getValue, majority is equal to entry.getCount. Okay, cool. So and then finally return majority. All right. Null cannot be converted to int, line 10. Oh! Well, if it's null, we guess we're gonna return a sentinel value. How about that? entry dot. Oh, what the hell did I do here? Get key. My bad. Is that depicts the number? Might not have been initialized. Oh yes, definitely. We only want to update after it has failed the test or passed the test. Might not have been initialized. Majority. We want to have a sentinel value here, I guess, too. So what do we want to return? Let's just return this. Oh. Cool. Submit. Oh my god, that is horrible. Faster than 33%, less than 45. I thought, wow. Okay. Let's look at the solution then. Brute force. N squared. Hash map. This is what we did. Let's look at their code for the second approach. Why is our space so bad? Why is our time so bad? I don't get it. Okay, so here's the thing. They're iterating through the array. Just like the way we're iterating through the array, and they're putting it in the map. And in order to traverse through the map, they're using map.entry. Where did they call the majority element? It's weird. Okay, anyways. And then they're traversing through the map too. Boy. In login 1. Whoa, there are like a lot. What? There's a divide and conquer? Oh god. Okay, it's not that great either. Oh, this is smart. This is amazing. Yes, of course. Definitely. We don't need to do another iteration. Jesus. Okay, so there are like a lot of solutions. Random, we'll look over them, but none of them is a clear winner here because we have pitfalls in every of these solutions. So any one of them works. I'm kind of happy with the hash map thing, but yeah, it's true. We don't need to traverse through all of them. So here's what we're gonna do. Because if yeah, we did go through this logic, right? Which is pretty stupid because we went through this, but we didn't think like this. If one of the counts uh, crosses n by 2, we're not going to have a majority element. We already have our majority element then. So if num count get the value in I is greater than nums dot length, wait, array dot length, yeah, okay, so array dot length by 2. That means, oh, that means we've already found uh, our majority element. And we don't need to go through the entire hash map either. But actually, this should do the trick because we're guaranteed to have um, a thing more than a number which uh, appears more than n by 2. We're guaranteed to have a majority element, so we just need to return that the moment we spot it, which is clearly going to go inside the else statement every time we're populating the hash map. So once we have populated it, obviously, so the if statement comes later, return nums dot length. Oh, sorry. Num count. Oh, well, return I. Yeah. How about we remove this? Let's see what happens. Hopefully this will be slightly better. What? Oh, of course. How about now? Using return statement. Return sentinel value. Because we'll never. I guess we won't. Hopefully. No? Okay, let's do this. What? Okay, nums.length by 2. Okay, so what do we get here? Oh, we want to have this if statement on both cases, yeah. Because it might have like one value and never enter the else statement. So yeah. How about now? Why is it even worse? Why is it even worse? We just improved the memory, but that's it. Why? We just removed map.entry2. We're not traversing through the hash map second time either. Eh, okay. Well, I don't think the other solutions are that great. Because this one is O(n) squared, so it's bound to take more time. We'll go through them later. Sorting also takes more time. Like randomization, this takes infinite time, so it's definitely not acceptable. Divide and conquer. We'll look at approach 6 later, I guess. But okay.